Hello guys, in this video I'm going to show you how to solve alien dictionary problem. So there is a dictionary containing words from an alien language for which we don't know the ordering of the characters. Write method to find the correct order of characters in the alien language. Right? So it sounds a little bit sounds a little bit complex, but let's see how we can formalize it or paraphrase it into a well-known pattern, right? So let's see the explanations here. So for this given input, we have a list of words, right? And these words are sorted in dictionary order, right? So let's say, for example, in English dictionary, the word let's say what is apple will come before let's say ant. No, let's say another one. Let's say will come before, let's say ace will come before apple. Why is that? We first compare two first character, right? And it's the same. So what is the next? Compare the next characters C and P. Is obviously that C comes before P. So ace will come before apple in the dictionary, right? But here we have a alien dictionary, right? Alien language. So the order will be, it can be whatever it is. So let's say, so for example, if we first compare these two first, right? These two first characters. This one comes before this one in dictionary, so it means Y will come before W in the dictionary, right? Here is what we can conclude from these two words. Next, we have these two, and same logic, we can conclude W, two first character, W come before X. Here's the interesting part. X is the same, so we move on to the next character, W and Z. So W will come before Z, right? So on and so forth. We have a total of 5 pairs of words, and based on these conclusions, we can eventually conclude the final order, right? Which would be Y, W, X, Z. So the key point here is to formalize these piece of information into something we are used to, which is a graph, right? So we have a characters comes before a character So these can be represented as 2 points in a graph. So point y will point to w in our graph, right? And so on and so forth. So we will build a graph out of these informations, right? So our goal is to find the correct order of characters in the alien language, right? So in the final output, y must come before y must come before w, right? Here y w x c, y must become w, right? So so after formalizing it into a graph, and a directed graph, it is quite clear that one must use topological sorting to sort it to put the characters in order, right? Topologically. So in this, if you don't know what topological sort is, please take a look at our previous problems in this category. Okay, so let's try to summarize what we need to do here. Okay, we need to compare, right? We compare two next words, right? From this sorted order, okay. And we need to conclude. We need to find two order of two character in dictionary. We need to build a graph, right? And for topological sort, we only need to keep track of a incoming maps, right? Incoming maps is a map of key value in which key will be the characters and value. Key will be the node in the graph, and value will be number of dependencies that pointing to the current node, right? To the key. Okay. After this, wanna sort. Do topological sort. Okay. So first, we need to init graph and incoming map. For graph, wanna use a map, right? Wanna represent a graph in adjacency list, which is a map, where the key is a node and the value will be list of destination node, right? Incoming here, will be also a map where the key is a node and the value is a number of dependencies. And here we need to initialize our graph incomings, right? So to init graph incoming map, so the idea here is to iterate to every character, right? Each character would become a node in our map, right? So first iterate through the words, that word of words, okay, and I'm going to use a nested loop here to iterate through the character of what, okay. Okay, I will put this character into the graph, right? But only if it is not in the graph yet. So if it is graph doesn't have the character, then I will set it character here. Set it with an empty array. Then I will graph. I will add. What is that? Okay. No. For this step, we're just gonna initialize a graph, right? If it is not in the graph, I will set it as a node. Set a new item with key is a characters and the value is an empty array that later will contain destinations node, right? And yeah, so it is already in the graph. I just want to skip it here. Okay, so next thing is the incoming maps. If same here, same logic. If it is not in the incoming maps, I set it incoming. I set the character with a value of 0, means it had 0 dependencies. Okay, that is it. Next step to compare to next one. To words that is next to each other. So I'm going to use another loop here. Why start from 1? As long as less than I, less than words start length I plus plus. Okay, so when I compare the previous word would be words at index I minus 1 and current word would be words at index I. I'll compare these two to find the two characters, right? Two characters in order in dictionary order. So let's abstract the logic into a functions. Find order of chaos. By chaos order. This will take into word, previous word, current word, and will return an array so that I can destructure into pre-character, ref character, and current next character. Let's say we need these functions to be implemented. Current word, next word. Let's leave it for later. So we have two characters. He will be the source node, and here will be the destination node. Right. So I will just feed our graph with these two. First, get the node in the graph with key of previous char. This return an array of destinations nodes. So I will push the next character in. Next character, okay. And what else? We need to update incoming as well. Incoming, I want to set the item with the key of next character, which is a destinations node. I will set it with 1 plus the current value, which is incoming get next character. Okay, so we're done here. So in order to do topological sort, we need to in order to do topological sort, we need a queue. We need a queue. Name it sources. Right, here is a queue that will contain the node that is available, that is ready to put in our sorted list. Sorted order would be a string, right? So we need to initialize the sources first. So I will initialize it with all the characters that has no dependencies. So we'll do that by checking the incoming maps. So for each key will be destination, characters, and valid with number of dependencies. We'll iterate through key value of incoming maps. So if the number of dependency is 0, so it could be it could be a candidate to put in the sources. Sources will be the queues. I will push and ship, put in one line and take it from the other end, push sources, destination character. Okay, so topological sort. We will use a loop, right? We're gonna process one node from the sources for one loop, for one iteration. Okay, so it means as long as the sources, as long as we still something with the sources, we want to process it. And before that, just return the sorted order at the end. So process it by first taking it out from sources. Let's say character out will be sources. Ship method will take it from the head of the array. Character out, I will put it, just add it into sorted order. This will be a let, so that we can modify value. Character out. So one final thing is to update the incoming maps, right? So by putting this character into the sorted order, the incomings, we need to update the incomings map, right? Because the number of dependency has changed. For the node that is the destination node of the node, character out here, right? So just want to so we must find all the destination node of character out here. So I will do it by that something here of I'm gonna use graph here to get the destination node of one node. Graph get get the character out. This return a list of destination node, right? Destination care. So I need to update the incomings of this one. So it will be the same logic as here. So I will update the value of destination car by taking the current value of destination car and -1. So one last thing here, if so after these operations, the value can be 0 here. So if it is 0, it can be a new candidate to put in the sources. So if this is which is 0 here, I will put it into sources and push into destination. One last thing here is to find the characters order of 2 words, right? So the logic here is to to check, right, to start from beginning of each character, right? Then start to compare the characters. If it is equal, want to move to the next character. If it is different, want to return those two characters. So let's use a counter here. I start from 0 means index 0. So as long as I is still less than current word dot length, I is still less than next word dot length. Here I want to make sure that we have two characters to compare, right? If we exit here, it means we go all the way to the end, but couldn't find two characters that are different, so I'll return no here. Here, if the current word I is different than the next word, but the next I will be different, so return it in the same order, return two characters, right? And if we don't return here, I will just increment the pointer by 1 to compare the next two characters. Okay, I think that is pretty much it for this one. Just 16 4. Hopefully it will work here. Okay, awesome. It worked right in the first time. Just double check it one more time. Okay, awesome. So that is it for this video. Alien dictionaries with topological sort. Thanks for watching. See you in the next one.